Hello dear student, today we will learn about PCR and its application. So first of all we should know a little bit history behind this technique. So among three methods, that is the cloning, DNA sequencing and the PCR. PCR is the oldest in theory and most versatile in practice. The method was first proposed in early 1970s by H. Hobin Khorana and his colleague as a strategy to lessen the labor involved in chemical synthesis of the genes. Their ideas, however, did not seem practicable at a time where genes had not yet been sequenced. Thermostable DNA polymerases had not been described, and the synthesis of oligonucleotide primers was more of an art than a science. Not surprisingly, Corona ideas were quickly forgotten. The technique was independently conceived 15 years later, given its present name, and put into practice by Carrie Mullis and co-workers at Citus Corporation, who describe in vitro application of single copy mammalian genes using the cleaner fragment of Escherichia coli, DNA polymerase 1. So PCR would be probably have remained a clumsy laboratory curiosity were it not for discovery of thermostable DNA polymerases. The use of thermostable polymerases from Thermus Aquaticus greatly enhanced the efficiency of PCR and opened the door to automation of the method. By the end of 1980s, the cloning was no longer the only way to isolate genes. DNA sequencing had been revolutionized, and PCR had become a fundamental cornerstone of genetic molecular analysis. So, the PCR allows the rapid synthesis of designated fragment of DNA. Using the technique, over 1 billion copy can be synthesized in a matter of hours. PCR is a valuable tool to the scientists by assisting gene mapping, the study of gene function, cell identification, and forensic scientists in criminal identification. Citus Corporation, uh, the Mullis employer at the time of his discovery, was the first to commercialize the PCR process in 1991. Citan sold PCR patent to Hoffman La Roche for a price of 300 billion million dollars. It is currently an indispensable tool for molecular biologists and development of genetic engineering. Mr. PCR, the Carrie B. Mullis. In 1983, working for Citrus Corporation, Mullis developed the polymer chain reaction, a technique for the rapid synthesis of a DNA sequence. The simple process involved heating a wire while containing DNA fragment to split the two strands of the DNA molecule, adding oligonucleotide primer to bring about reproduction, and finally using polymerase to replicate the DNA fragments. Each cycle double the amount of DNA, so multiple cycles increase the amount of DNA exponentially, creating huge number of copies of DNA fragment. Willis left CITES in 1986. For his development of PCR, he was co-awarded the Nobel Prize in Chemistry in 1993. So, what are the problem? How do we identify and